right. I'd like to take this opportunity and discuss IRR, APR, EAR, and applications. Okay. So, first of all, IRR stands for internal rate of return. All right. APR stands for annual percentage rate. Okay. And EAR stands for effective annual rate. All right. So in many cases, the last two actually have some variants. For example, in the context of bonds, you may have heard things called annual percentage yield, APY. All right. In the context of bonds as well, you may have heard things like effective annual yield. All right. So they're the same concept. Okay. In your Finance 201, you discussed what is IRR. It's the internal rate of return, or in other words, it's the discount rate that makes the present value of the future cash flows equal to the initial investment for let's say a capital budgeting project. Okay, so in this discussion, I'm going to discuss overview of the IRR, APR, and EAR, and later I'm going to move on to the discussion of the applications. We're going to focus on two important applications of effectively EAR. All right, so as you will notice, these two applications are actually very, very important because it does affect how you can actually, for instance, decide among different mortgages or, make, financial decisions regarding whether you want to buy or lease, for example, a computer or an airplane. All right, so let me just motivate, EAR here. Okay, so I'm going to use one example from the lecture note just to motivate this, concept. All right, so example number 1 on your lecture note. Okay, so let's say you're shopping around and you're trying to, look up a bank where you can actually make a deposit. All right, so this is about shopping, banks. Okay, we know that with the emergence of, financial technology, the traditional banking industry has been, dealing with a lot of challenges, especially from the, high-tech, startup companies in fintech. All right, for example, these challenges could be, centered around, payment. You guys have heard of, buzzwords like, cryptocurrencies, bitcoins, and so on and so forth. Okay, it can also, affect, for instance, the way people, invest. The wealth management, insurance, and so on and so forth. All right, so back to the traditional landscape, you're actually shopping banks, and you have 3 banks here. All right, Bank A and the Bank B and the Bank C. So I'm just too lazy to, type down all the, things. So I'm just going to copy it down and change the names. All right. So you're looking at Bank A, and this is actually quoting you a 15%. All right, and also it's actually dealing with daily compounding. Okay, so excuse me, daily compounding, that is our compounding parameter. Remember, this is the K. All right, so I would say 15% is the rate, and this is our K. K is defined as the compounding frequency, which measures the number of compounding times in a year. In other words, the number of times your money grows interest in a year. All right, Bank B, that's 15.5% interest rate, and it's actually compounding quarterly. So K is equal to 4. Bank C, it's actually 16%, and it's actually compounding annually. So K is equal to 1. All right, so the question here is very simple. Which bank for a deposit? And which one for a loan? Okay, so All right, you might be saying, you know what? If I want to make a deposit, I want to earn the most interest. So across the three banks, it looks like Bank C provides the highest interest rate. So I should go with Bank C. Now, the problem in this, methodology, in this thought, is that you are ignoring the compounding frequency. So really, you should consider both, this quoted rate and also, the frequency at which your money grows interest, right? So how about we start with a hypothetical $1, okay? So standing today, I have collected all the information. I'm just going to find the future value of the $1 deposit in a year. Okay, so how about this? All right, well, that is something I can do very conveniently. So future value in 1 year. Okay, so I'm going to actually look at future value if I go with the first bank. Okay, so I make a deposit of $1 today, and in 1 year, I'm going to find out how much I'm going to have. So I can do the formula, which is, future value equals present value, which is $1, multiplied by 1 plus the interest rate, which is the 15%. But remember, this actually is daily compounding, so I should divide this by 365. So this is the R over K, and this is raised to the power of K, which is 365 times T, which is 1 year, okay? So that would get me the future value of Bank A, in 1 year. All right. So just to highlight this, double click the cell and show you the formula here again. All right. And now I can actually copy it down and say, you know what? I can actually calculate the future value of the other two banks as well. And if I want, I can actually format this, so that they actually have the same decimal. It's easier for me to compare. Okay. I keep 4 decimals here. All right. So you see that, from the calculation, you should go to, Bank A, excuse me, you should go to Bank B for a deposit, because this way you earn the most interest. And the Bank C for a loan, because, the future value is the lowest. So you end up paying the least amount of interest. All right. So this way you can actually solve this problem. But you notice that the methodology here, there's only one nuance here, which is the future value in cells, F12 through F14. Well, these future values, that depends on the initial investment. Okay, so if I want to actually get rid of this dependence, if I want to get rid of this initial investment effect, I should probably, okay, to address this, all right, I should probably consider, the rate of return. All right, I'm taking a lot of notes here so that it's easier for you to, understand when you review this, okay? So I should probably consider the rate of return, if I go to different banks. So let's just look at rate of return here. If I look at Bank A, how do I calculate the rate of return? Well, remember, today you started with $1, and then at the end of the year, you end up with $1, $1.1618. So really, your rate of return is where you finish minus where you start. So if I just do that, you would get the dollar return. Of course, I'm going to actually divide this by my initial investment. That's $1 here. So if I do it this way, I actually get a percentage, which is actually 16.18%. Okay? So this way, it's a percentage. It does not have any unit. All right? And it's very easy for me to compare across different banks now. All right? Without, having to wonder what is the initial investment. Okay? So now I can actually copy this down. Again, I can actually format this, so that they're showing as percentages and they're showing more decimals. Okay, so you see that now when I look at Bank B, this is 16.42%. If I want to actually make a deposit, that's the rate of return I can actually earn over the course of the year. So it doesn't matter what your initial investment is. You can start with $1,000 or $1 million. It doesn't matter. All right, you're going to earn 16.42%. It's very easy for us to compare across different banks. Okay, so in this discussion so far, all right, just to sum up, okay, the rates in C12 to C14, these are stated rate. Okay, in some other cases, they are the quoted rate. Okay, some other cases, people refer to as nominal rates. So they are referred to as APR. All right, whereas, the rates in, H12 through H14, well, these are actually considering not only the effect of the quoted rates, but also the compounding frequency. All right, so these are the real or the effective or the actual, rates. And for this reason, we refer to them as EAR. All right, so, these are the EARs, these are the APRs. Okay, so this is very, straightforward now based on this, a simple example. All right, so now you can actually see, you can actually go back and forth between, EAR and APR. Okay, so conversion between EAR and APR. Okay, so if I want to, go from, APR to EAR, all right, so to calculate, EAR by, using APR, what should I do? Well, there are two ways for you to do it. One is there's a formula, okay, and there's an Excel function. All right, so I'm going to share with you the Excel function here. It's called effect, okay? And you're going to put down the APR, and then going to put down the compounding frequency, which is the K, or the number of periods in a year. So that is the, Excel function. I'm going to show you one example in a second. All right, if you want to actually do the formula, you have the formula on the lecture note that says EAR is equal to 1 plus APR over K, all right, raised to the power of, K minus 1. All right, so that is the, one-way traffic. If you know the APR, you want to calculate the EAR, you have two options. All right, if you want to do the opposite, to calculate the APR, by using EAR, okay, what should you do? Well, there's a formula as well, but I'm going to skip the formula because really you're just going to manipulate, this, equation and back out APR. All right, so instead, I'm going to show you this Excel function here. It's called nominal. All right, so you see that when you type equal nominal, Excel says this function is going to return the annual nominal interest rate, which is the APR. All right, so it takes similar arguments. It takes EAR as the first argument. It takes the compounding frequency parameter K as the second argument. All right, so that's a very simple the conversion. And remember, some other times APR is actually defined by or is actually calculated by the compounding frequency parameter times the period rate. Okay, so in other words, if you know the monthly interest rate is 1%, if it's monthly compounding, then the APR is going to be 1% times 12, which is 12%. Okay, that's actually how banks calculate their APR. All right, so bear that in mind. Okay, and let's just look at one example here, and let's just see how we can actually. All right, I'm going to make up one ad hoc example here. Okay, so let's say you're going to become a loan officer. All right, after graduation. You prefer to work for a commercial bank, all right? And you're going to actually review people's credit application, essentially their application for, loans, and you're going to actually evaluate and see whether, this is a trustworthy, borrower or not. If the borrower is actually creditworthy, is trustworthy, you might want to extend the loan, okay? So you're a loan officer, and let's say, you want to actually earn let's say 18%. And you want to actually, ask for, monthly payments. Okay, so the question is, what rate do you quote? Okay, so this is a very simple example. All right, in our framework, if you want to actually earn 18%, well, 18% is going to be your EAR. And if you want to ask for monthly payments, so whoever is borrowing from you, you ask, monthly payments. And so you need to find, the APR. All right. Okay, very simple analysis. So I know already from the Excel function, if I would just want to find the APR, I can just say, my APR is equal to nominal. All right, I'm going to take the 18%, and that is the effective annual rate. And I'm going to throw in 12 here because that's the compounding frequency here. And so you see that if you want to actually earn 18%, you don't have to quote 18%. You can actually quote just 16.67%. Okay, so this actually is some people may say this is really misleading. All right, you're not quoting 18%, and yet you're effectively earning 18%. Okay, so that is the simple takeaway. All right. So that is the the motivation and a little discussion in general. All right. So now I'm going to talk about IR EAR application 1. Okay. Mortgage analysis. All right. So we're going to actually start with a very simple mortgage. Okay. So let's look at example number 4 on your lecture notes. All right. So let's say your bank has agreed to give you a $100,000 mortgage to be repaid over 10 years at 8% interest. Okay. Again, please have your lecture notes side by side. All right. For simplicity, we assume that the payments on the mortgages are annual. Okay. So you're talking about a loan, which is $100,000. And you're talking about, the term, which is actually in years. And this is a 10-year loan. And you're talking about interest rate. And this is really the APR, and that's 8%. Okay. And then, you're trying to, find, annual payments. Okay. And so the question here is, first of all, what is the annual payment? All right, and secondly, what is the EAR? All right, so that is the setup for this question here. So, you're going to pay, equal annual payments. All right, so what's the analysis? All right, the analysis here is, this is a annuity. Okay, as we're saying, all the requirements for annuity is, they are satisfied. For example, it's for 10 years. The rate does not change, and it's equal annual payments. Okay, so if I want to find the annual payment, I can certainly find the annual payment by the Excel payment function here. All right, so the Excel payment function calculates the constant cash flow per period for an annuity. So the rate is 8%. This is annual compounding, so we're good. Number of period here is 10. And the present value is the loan you're getting. So that's 100,000. It's a loan. So it is cash inflow. It is positive. And then future value is 0. And type, by default, if we do not specify, then we say these payments are actually coming in at the end of each year. All right. So you can skip type or you can put down 0. All right. So that is $14,092.95. It's negative because you're paying this every period. Okay. So what is the EAR? All right. So here, EAR is the, you may ask me, hey, why do you want to discuss EAR for mortgages? All right. So this is the answer. Okay. Remember. All right. EAR is the I should say EAR is measuring the true cost of mortgages. Okay? So whenever you want to compare different mortgage options, you should actually look at the cost of the mortgage, and you should really look at the cost by using the EAR. You should not be misled by APR or other fees or other features or IRR and so on and so forth. Okay, those are not appropriate. All right, they are not measuring the true cost of the mortgage. Okay, so just bear that in mind. All right, I'm going to show you how to find the EAR for different mortgages, even mortgages with different options. And so this is the starting point because we're actually dealing with a very simple, plain, vanilla mortgage. Okay, later we're going to actually throw in a few more realistic features of mortgages, and you can actually see how we can actually incorporate this, realistic features, into our analysis. Okay, so if I want to, this is a starting example. All right, that's why I say this is a plain vanilla, mortgage. All right, so if I want to actually measure the EAR, to calculate the EAR, we should actually focus on the cash flows from this mortgage. Okay, so I'm going to actually look at the cash flows from this mortgage, and I'm going to actually build a timeline and indicate the cash flow. All right, so this is a 10-year mortgage, so I'm just going to build a timeline for 10 periods. All right, this is 11, so that's not necessary. And I'm going to look at the cash flow per period from this mortgage. Okay, so we know that today you're going to receive 100,000. All right, and then in one period you're going to pay 14,902.95. That is your first annual payment. And earlier I discussed the notion of absolute self-reference, and here I want to use it again. All right, so remember, if you want to invoke absolute self-reference, you simply press F4 if you're using the PC Excel, or you can just manually type down $E $47. All right, so that would do it as well. So I can now copy this across. These numbers, they are all hidden. As I said, they don't have enough space to display. That's why they are a little shy. Okay, so we're now bringing these numbers back, and we have this 10 periods. So that is the structure of this mortgage. We are focusing on the cash flows. All right, so now I'm going to actually look at IRR of the cash flows. Okay, so this is going back to your finance 201. So what is the IRR of this cash flow? Well, the IRR is the discount rate that makes the present value of the future cash flows equal to the initial investment. All right, so if I want to calculate the IRR, I'm just going to look at the IRR function. Okay, later when we actually move on to capital budgeting, you're going to actually understand under what conditions can you actually use IRR function to find the only IRR. All right, in this case, the initial loan is positive, and then the sign for the cash flows actually changes to negative, and it stays negative. So according to some magical math, there is only one IRR in this case. So I'm going to actually look at all these cash flows here, including the initial $100,000 loan. All right, and I don't have to deal with any initial gas. All right, so I just press enter, and Excel says the IRR is 8%. All right, so I can actually bring up the decimal here as well, and this is 8% exactly. Okay, so now how do I get EAR? Well, remember, I should actually go back to my notes here and say IRR is a kind of period rate. Okay, so if that's the case, well, in our example, IRR is the monthly interest rate. So I can now calculate APR. All right, APR in this case is equal to IRR times 1, because this is annual compounding. You're making annual payments. Okay, so that APR is 8%. And now I can actually calculate my EAR, and that's going to be effect APR, which is 8%, which is what we just calculated, and 1 here. All right, so the EAR for this mortgage is 8%. Some of you will say, what's the point? We know the APR is 8%, and you just calculate the EAR, that's also 8%, and this is annual compounding. All right, so for annual compounding, all right, APR, IRR, EAR are all the same. Okay, so that is more like an exception than a norm, because if the compounding frequency is not annual, then they're going to differ. All right, so that is a very simple analysis of this plain vanilla mortgage. But the beauty of this methodology is that it actually lays the foundation for the analysis of future more complicated mortgages in a minute. Right? So this is example number 4. All right, I hope this is very straightforward for you to follow. And now let's actually look at example number 5. All right, and this is no longer a plain vanilla mortgage. This is actually a mortgage with points. Okay, this is actually very realistic. If you go to the financial market, if you go to the real estate lending market, if you ask for a mortgage, in most cases, the mortgage lender is going to actually quote you, some different rates with different points. You may have heard of like 1 point or 2 points or 1.5 points and so on and so forth. So how do we analyze this? All right, so let's look at this example here. All right, so let's say, it's a still for, a $100,000 mortgage. Okay, it's a $100,000 mortgage, and it's still annual payment. Okay, and actually your annual payment is actually the same as example number 4, $14,902.95, and the term is still 10 years. All right, so these are all the same, and the interest rate is still 8%. Okay, that is the quoted rate. That's 8%. All right, but then you realize that the bank is telling you one more interesting thing. The bank says you actually have to pay 1.5 points. Okay, so what is a point? All right, so there are a few things for us to know before I actually proceed any further. Okay, there are many different kinds of interpretations for the points, but the simplest way is to realize the following. Number 1, a point. 1 point is a percentage. It's 1% of the amount you borrow. Okay, so in this case, if you're going to borrow $100,000, then 1 point is going to be 1% of that. All right, so whatever that is. Okay, 1.5 points. Well, that's just going to be 1.5 percent of the amount you borrow. So whatever that is. Okay, and secondly, you may wonder, when are the points paid? All right, the easiest way is to think of the points, or the point cost is deducted upfront. Okay, in other words, you go to the bank, and bank says, in order for you to get this 8% interest rate, you have to actually buy 1.5 points, which means the bank is going to actually do the following things. First of all, 1.5 points is 1.5% times $100,000. So you do the algebra, I believe that's 1,500. And secondly, bank says, because you have to actually buy 1.5 points, and that is equivalent as $1,500. So I'm going to actually knock off this 1,500. I'm going to deduct $1,500 upfront. So the check I'm going to hand you is going to be 100,000 minus 1,500. Whatever that is. Okay, so the point of cost is actually deducted upfront, and these creates a difference between the amount you borrow, okay, which is the amount you need to pay off. The amount you need to pay off, and the amount you get today. Okay, so this is very, very important. All right, a lot of times people struggle to actually incorporate or analyze points because they do not realize these two important things. All right, so now I'm going to actually look at how much more costly this mortgage is. Okay, what is the IRR for this mortgage in this case? Well, is it still 8%? Well, some of you will say, apparently this is more expensive than 8%. How much more expensive? Well, you have to pay an extra of $1,500. So it is actually more expensive by $1,500. But that is kind of, confusing. That's kind of, inconvenient because on one hand, I'm saying the quality rate is 8%. On the other hand, I'm saying I have to actually pay an extra of $1,500. So the question really becomes, can I actually compress these two pieces of information into one simple measure, which is the cost of this mortgage? I want to be able to do that because I want to compare different mortgages. So I have to actually, come up with like a percentage number. In other words, what is the IRR? Okay. So speaking of that, we can now, follow our same methodology, in the previous example, and we're going to look at, okay, to find the IRR of this mortgage. Okay. Again, we're going to focus on the cash flows from this mortgage. All right. So I'm going to actually, build my timeline here again. All right. So 0 is for today, and this is one period from today. All right. I'm going to look at, 10 periods here in total. All right. And I need 2 more. And I'm going to look at the cash flows per period. Okay. So I know that in 1 year, I'm going to pay $1,492.95. Why is that? Because I still borrow $100,000 and I need to actually pay this off in 10 years using equal installments. And the rate is actually quoted as 8%. So I can do the same trick, 8%, 10 years. The loan is actually 100,000 and future value is 0, type is 0. So I'm paying this at the year end. So that's $1,492.95. All right, so I can copy this across. These are all the annual payments. They are equal, and that's an annuity. And now let's look at what is the cash flow today. Well, some of you will say, isn't that $100,000? Well, remember, in this case, you have to actually pay the 1.5 points. So the 1.5 point, well, that's actually 1.5% times 100,000. And the banks are going to deduct this, dollar cost up front. So really, the amount you get is going to be 100,000 minus 100,000 times, 1.5%. Okay. So if you do that, you're going to get the amount, and that is the amount you're getting. Okay, note this is the amount you get today. It is less than the amount you borrow by $1,500, which is the 1.5% of the of the borrowed amount. Okay, so this is now very important. All right, so immediately you realize that this is apparently different from the mortgage in the previous example. In the previous example, there's no point, so you just borrow 100,000, you get 100,000 as well. In this mortgage, you borrow 100,000, but you actually get 98,500. All right, so now I can actually say what's the IRR of the cash flows. So I can now look at IRR of all these cash flows, and this is using the IRR function again. And there's not only one IRR because the sign for the cash flows only changes once. All right, so I can actually see this is also 8%, but if you actually bring up the decimal, this is actually 8.34. All right, 8.34%. So now I can actually say, hey, what is the APR and what is the EAR? Okay. So if I want to calculate APR, just remember APR is actually calculated by multiplying the period rate, which is the annual rate here, by the compounding frequency parameter, which is 1. Okay, so that is 8.34, and EAR is equal to effect APR and 1 here as well. So that is 8.34%. All right, so that now answers the question of how much more this mortgage is. Okay, you can actually say this mortgage is more expensive than the previous one. And it is how much more expensive? It's actually 0.34% more expensive. Okay, so you see that we have successfully translated the $1,500 into the percentage. The $1,500, if I actually find a way to factor that into the increase in the percentage, well, that's 0.34%. So you see the beauty of this methodology here. All right, example number 6. Okay, so let's now move on to more realistic examples, and let's look at example number 6 here. This is now mortgages, and actually I should say mortgages with monthly payments. Okay, so now we're actually getting closer to the real world. We started with the annual mortgage, and then we put back the points, and now we actually extend to monthly mortgages. All right, so mortgages with monthly payments. So let's just say this is $100,000 mortgage. All right, example number 6, and interest rate is still 8%. This is the annual rate, and you're paying monthly now. Okay, monthly payments. All right, and the term is actually 1 year. Okay, which is 12 months. And if that's the case, what is the EAR of this mortgage? Okay, what's the EAR of this mortgage? All right, so if I want to find the EAR, I follow the same methodology. I look at the cash flow, I calculate the IRR, and I convert that into EAR. Okay, very simple analysis. All right, so focus on the cash flows. Calculate the IRR and convert into APR and EAR. All right, so that's our methodology. Okay, so I'm going to, first of all, I'm going to look at the monthly payment. All right, what is the monthly payment here? So you're making equal monthly payment, so that's an annuity. So I can use payment function here to find the constant monthly payment. The rate here is 8% over 12. MPER is 1 year times 12 months per year. Remember, everything in Excel function is in periods. In this case, it's in months. And the present value is the loan. That's 100,000. And future value is 0. Type is 0. So you're actually paying $8,698.84. All right. So that is the monthly payment. If that's the case, I can now look at timeline for this mortgage. This is 0. This is 1. And I'm going to look at a total of 12 months here. So I have 11. I just need one more. All right. I'm going to look at the cash flows per period. So I know that in the first month, I'm going to pay this amount here. And it's the same amount for other months as well. So let me use absolute self-reference. And let me just copy this across. These are the monthly payments. They are the same. And here, well, this actually is the loan. So you're getting 100,000. All right. So if that's the case, I can actually look at what is the IRR of the cash flows. Okay. So again, I'm going to do the IRR function here one more time. The cash flows only changes signs once. So there's only one IRR here. So I'm just going to use all these cash flows, and the IRR is actually showing up as 1%. But it's always a good habit to bring up a few more decimals. So this is 0.667. All right. If that's the case, I can look at what's the APR. Well, APR is equal to the monthly interest rate times 12. So that's showing up as 8%. And I can also look at what is the EAR. Well, the EAR is equal to effect, the APR, and 12. Okay, so in this case, the true cost of the mortgage is actually 8.3%. Right? This considers, the quality rate of 8%. This also considers the fact that this is a monthly mortgage payment mortgage. All right, so very straightforward. And now let's look at example number 7. Okay, so monthly payments plus points and fees. Okay, so this is now a lot closer to the real world mortgages. So we have points, we have fees, and we're just trying to actually analyze the mortgages here. Okay, so let's just say you have this, a mortgage. The loan is still 100,000. Okay, this is 1,100,000. All right, 100,000, and it's interest rate is 8%, and you have monthly payments, and the term is still 1 year. Okay, but the interesting thing here is that you're going to actually pay the origination fee, and that is 0.5%. Okay, and also the point, which is actually 1 point. All right, so this mortgage is probably a lot closer, a lot more similar to the ones your parents might be getting. So the question is, what is the real cost of this mortgage? All right, so in this case, you see that the mortgage actually has fees and also has points. Well, the origination fee is very easy for you to understand. The mortgage lender says, we're going to actually, we'll review your application, and if your application is, approved, we're going to actually set up the mortgage account, and we're going to send you, the payment notice, and we're going to, provide you with the tax document every year when it is time for you to actually file your tax return, and so on and so forth. And this is costly. We're going to charge you 0.5% of whatever amount you borrow. Okay, so that is the notion of origination fee. All right, in the real world, mortgages actually have a lot of other fees, like for instance insurance, title, search. You have to pay the title company. They have to make sure the house you're going to buy has a clean title. All right, and so on and so forth. All right, so again, I'm going to do the same thing, which is actually focus on the cash flow and get the IRR and calculate into EAR and APR and EAR. All right. So first of all, I'm going to look at a monthly payment here. All right. So in this case, your monthly payment is going to be based on the amount you borrow. All right. So I'm going to do the payment function here again, 8% over 12, and this is for 12 months. It's for 1 year, and the loan is actually 100,000. And feature value 0, type is 0, so that is the same $8,698. All right, now let's look at the cash flows from this mortgage. Okay, I'm going to build a timeline, and I'm going to actually I have this timeline here, so why don't I just copy and paste it here? Oops, I just copy and paste it here. All right, so I have a 12 period timeline now. All right, and I'm going to look at the cash flow per period. Okay, so we know that in the first months you're going to pay this amount. All right, and you pay this 12 times in a year. So I'm using just do the cell reference again. And now let's look at what is the cash flow today. In other words, what is the amount you get? So the amount you get is based on the amount you borrow, which is 100,000. Okay, but then you have to pay the point, which is 1% of the amount you borrow. Okay. In addition, you have to pay the 0.5% of the origination fee. So 0.5% times the amount you borrow. Okay. So that is getting you 98,500. This is by coincidence. All right. It's the same amount as you see from example number number 5. Okay. So in this case, the amount you're going to get is actually smaller than the amount you borrow. All right. So if that's the case, I can now look at what is the IRR of the cash flows. Okay. And can I copy this one here? Actually, can I copy everything here? All right. So I'm just going to do it this way, and you can actually think about, hey, what's going on here? All right. So yes, I can actually copy across those things. And IRR of this mortgage cash flow is actually 0.904%, and APR is actually 10.85, and EAR is even higher. It's 11.41%. So the increase, I should say the EAR increases by, if you look at the quoted rate, that's only 8%. And this is actually 11.41%. So it's actually increased by 3.41%. And where does the increase come from? This is caused by the origination fee and the point cost. Okay, so these two things, they are actually making this mortgage a lot more ugly than the quoted rate. The quoted rate is only 8%. So if you actually sign this, agreement, they're saying, I'm only paying 8%, but you are misled. You're effectively paying 11.41%. This is their business. This is how they actually, make, profits. Imagine, as an educated, borrower, you would have to, look at all these different mortgage options and calculate the true cost and pick the one that has the lowest cost. All right. So this is actually, very, very important. All right. I think the video is actually getting a bit long here. So I'm just going to produce another video for the second application. I'll stop the video here.